So I have been talking to you about the properties of complementary and supplementary angles. And what is interesting to note is that a supplementary angle is one that adds up to 180 degrees, and it's 180 degrees is basically a straight line. A complementary angle is an angle that adds up, or angles that adds up to 90 degrees. Now, what we're going to be looking at today are the inside angles of a triangle. Now, there's something that I want to prove to you today, and that is that all the inside angles of a triangle equal 180 degrees, or in other words, they equal a straight line. And in order to show that to you, I'm going to demonstrate a little bit of magic. Now, you'll notice that I'm not using any form of protractor. I'm not measuring any angles here. So all that I'm about to show you is pure guesswork. It's just random triangles that I'm drawing, no measured angles at all. So what I'm going to do here is I'm going to draw a couple of random triangles. I'm just using the ruler to make sure the lines are straight, but I'm not measuring any angles at all. I'm just going to draw some random triangles, some obtuse triangles, some with acute angles, some with reflex angles. All I'm making sure is that the edges are straight and that the lines all meet perfectly at their vertexes. Let's see if we can squeeze one more in here. Now, when I'm done with this, part of your tasks for today will be to do this exact same thing, because I'd like to see these little triangles all stuck into your notebooks also, because this is important that you understand this. It will make what you're about to do mathematically so much easier to understand. So the next thing that I'm going to do here is I'm just going to label these. I'm going to call this angle, let's call this shape 1, shape 2, shape 3. So I'm going to call this A1. I'll call this angle A2, and I'll call this one A3, and I'll do the same for all the others. There's B1, B2, and B3. And now I've got C1, C2, and C3. And what we're trying to demonstrate here is that all the angles, that symbol there stands for angles, inside a triangle equal 180 degrees. We're trying to see if this is a fact, and we're trying to prove that fact. So what that means is I'm going to cut each and every one of these shapes out, and we're going to rip the corners off and just make sure that they touch at a common point, and this will determine, we'll be able to see after that whether or not indeed all of these angles do add up to 180 degrees, remembering that 180 degrees is a straight line. So I'm just going to cut this out as carefully as I can. I want this edge to be perfectly straight, because that's just going to make the end product that much more impressive. So just take note of how I'm doing this, because when you do it in your books, you're going to do a couple of examples in exactly the same way also. Now, this isn't to be confused with the other experiment that we did with the same red triangles in class. Remember, that one was to show why we use the formula half base times height divided by 2 when we are calculating the area of a triangle. Quick review there. Remember that that formula we divide by 2 because by the experiments that we did that day, we determined that a triangle is always going to equal half the area of a given rectangle or square. And that's the reason why we did that experiment. However, this is totally different. This is to do with the inside angles of a triangle, and whether or not they actually add up to 180 degrees. Okay, so here are my 3 random triangles. Remember, I did not use a protractor to measure these at all, and I don't know what these angles actually measure. we want to see if this is going to total 180 degrees. So I'm going to put these aside for now, and I'm going to work with this one here. Now what I'm going to do is I'm just going to tear the corners off, just like this, and we will discard the rest of the triangle because we don't need it. All we need are the vertices that have the angles. And I'm just going to make a dot on my desk here. Let me use a whiteboard marker. And that dot on my desk is going to represent the vertex that all of these must meet. Now what I need to do is make sure that angle A1, A2, and A3 all point to the same vertex, and I'm going to make their edges line up. And if indeed their edges add up to 180 degrees, we should have a perfectly straight line. Have a look at that. A perfectly straight line. Let me just overlap these so you can see it clearly. From all these angles. And here you see with the edge of the ruler along it that we indeed do have a straight edge along the side of these angles, which basically means that in order for these angles to create that straight edge, they have got to add up to 180 degrees. So let's try that with the other two. Here is our triangle number 2 with angles B1, B2, and B3. I'm going to do the same thing. I'm just going to cut the edges off. Just going to rip these corners off quickly. Get rid of that. And remember, this is a totally different triangle, unmeasured. And I'm just going to put all of these points together and see if these edges also make 180 degrees. There you go. Put the edge of the ruler along it to confirm. Those three angles make a perfectly straight line. So that angle, whatever it is, plus that angle, whatever it is, plus that angle, whatever it is, equals, let's call it B2 plus B3 plus B1. They all equal 180 degrees. We're going to do the last triangle just to show that it is any triangle that this works with. That was a bit sideways to the camera, sorry. Right, this one is an acute triangle. You can see there's a very, very thin angle there. Let's see if this one works too. Just tear off the corners. It's important that you label the corners first, otherwise you won't know. You might start measuring somewhere over here and you'll make a mistake. It's important that you mark the angles of the edges, the vertices that you want to try and experiment with. Put those two edges together and put that one there into the mix. And again, we've confirmed that these three angles inside this triangle all add up to 180 degrees. So I'm not entirely sure why this works. It just works. It's just the maths behind it and the physics behind angles and triangles. I would like you to try out this experiment. It's going to be part of the assignment for today. You're going to do this experiment, try with 3 or 4 different triangles, maybe get your parents or your friends to try it out also. I actually find it quite fun that any triangle you try, guess it. Just make sure the edges are perfectly straight and then it's a 3-sided figure. And those inside angles will always add up to 180 degrees. Now, that is important to remember because in the assignment that we're going to be doing, we're not just going to be trying to find complementary and supplementary angles. Now we're going to be taking that information that we know that complementary angles add up to 90 degrees, supplementary angles add up to 180 degrees, and we're also going to be including this new information that the inside angles of a triangle add up to 180 degrees. All of that information is what is going to allow us to get to the next step of this topic, which is how to calculate unknown angles, how to calculate the inside angles of a triangle when one angle is given, when only 2 angles are given. How do you know what the third angle is going to be? So it's going to be a little bit of addition and subtraction work that we're going to be doing here. I find it very exciting, and I hope that you find this type of maths exciting too. It's not formulas, it's not fractions, it's got its own set of rules. That's why we separate it from other topics like fractions. We're working base 180, base 90. So just keep those two numbers in your head and always remember that that's what you're going to be subtracting from, and you shouldn't run into too many problems. Okay, so I'm going to show you a couple of examples now on how we can apply this knowledge that the inside angles of a triangle all add up to 180 degrees. So we are going to be continuing with what we were just experimenting with when we were tearing up those little bits of triangles and putting all of their vertices and edges together to make a straight line. We're going to be looking at the more academic side of how the inside angles of a triangle equal 180 degrees. So I'm going to give it the title, Angles Inside a Triangle. And we are also going to look at the different types of triangles that we will come across in this lesson. So let's start off there. The main types of triangles that we will have to be dealing with will be, excuse me if they are not perfectly straight lines or if they're not all facing the same way. It's quite tricky drawing on a touchpad. Okay, this is what we call a right-angled triangle. And what this one it shows us is that, remember this sign here, just like when we're talking about angles, that symbol there, that circle, that square sign there basically means that it is a right angled triangle, and we know without having to measure that a right angled triangle is always equal to 90 degrees. Therefore, when we are now looking at these other two angles, we know that that one, so let's call this one A, let's call this one B, let's call this one C. We know that A plus B plus C is going to equal to 180 degrees. And in this case, we can substitute. We know that A is 90 degrees plus B. One of these will be given, plus C. We might be trying to find out which one of those is the missing fraction. So listen to me, fractions. The missing angle. I'm so stuck on fractions also. Basically, in such a triangle, a right angle triangle, you might see that, oh, there's only one angle that's been given. How are we supposed to calculate the other one? In actual fact, the other one has been given. When we get to the calculation part of this, I'm going to go over this in more detail. All the information you will ever need to calculate the angles is given. Even if it's not in front of your eyes, it is there. The next angle that we can look at is a scalene triangle. And a scalene triangle is one where all the angles and all the sides are unequal. I'm just going to redraw this one. So all the angles and all the sides are unequal. There are no angles, there are no sides that are the same. And in this one here, still A plus B plus C equals 180 degrees. And this is what we call a scalene triangle. And this is with no sides and no angles being equal. The next triangle that we can look at is, let's pick an interesting color we haven't used for a while, an isosceles triangle. Now, when we did our two-dimensional shapes, we looked at these little lines that appear on the side of shapes, and we spoke about what they mean. Basically, on this triangle here, remember it's a sketch, so we can't just look at it and say, ah, it's this or ah, it's that. There are mathematical symbols, even on a sketch, that are used in order to show, yes, it is actually an equal side, or oh, it is not an equal side. So in this case here, these lines are showing that that side and that side are the same. So if those two lines are the same, it means that these two angles are the same. So we would draw these with double lines also to show that that is the same as that, and that angle with one line is different. So it almost shows twins. This will be A plus B plus C, is still going to equal to 180 degrees. And an isosceles triangle shows that two sides and two angles are equal. So where you see these lines on the side of the triangle or on the side of at the angles, it is basically telling you that two sides or two angles are equal. So if I come back up to the scalene triangle, the way that we would label this or show this would be one line there, two lines there, and three lines there. Basically showing that none of the sides or angles are equal, or we could have one line there for that angle, two lines there for that angle, and three lines there for that angle, showing that all sides and all angles are different. And then our last triangle is going to be an an equilateral triangle. And the equilateral triangle is exactly what the name sounds like. It is an angle that is a triangle that is equal on all sides and all angles. I'll try and make this look as equal as possible. So that side is equal to that side is equal to that side. That angle is equal to that angle, and that's equal to that angle. So for a triangle like this, they might not label any of those angles for you, but they will show that that side, and that side are all the same, which will automatically, well, it should automatically trigger this in your mind. A plus B plus C is equal to 180 degrees. So if these angles are all equal, that means A is the same as B, which is the same as C, and all of them add up to 180 degrees. Without even having to calculate, you should be able to figure out that angle A, angle B, and angle C are each equal to 60 degrees plus 60 degrees plus 60 degrees. So just like the 90-degree sum, the 90-degree angle, when you see an equilateral triangle, you know straight away every single angle is going to equal 60 degrees. It doesn't matter how big the triangle is, it doesn't matter how small it is, it doesn't matter whether you've measured it in a maths book or in a science book or in a technical drawing book or on a computer. These facts remain the same, and it's important that you remember them in this way, because this is what the examiners call background information. When they set a question for you, for example, if this was a checkpoint question and they asked you what is angle C, they're deliberately not showing you what angle A and angle B is, so you wouldn't be able to substitute into the formula to do your subtraction sum from 180, which I'm about to show you how to do now. All they would do is label this triangle with its three sides showing that it's equal, and they will expect that you know that this equilateral triangle has all sides and all angles equal, hence the name equilateral. So I'm going to move on now to a split screen view of a specific type of question that you can expect to find in checkpoints. I'm just going to call this example 1. Now you've got your triangle here, and it is labeled 35 degrees, letter E, and 24 degrees. And you are needing to find out what E degrees is equal to. Now here's the thing. You know that all the angles equal 180 degrees. So in other words, you're going to have E degrees plus 35 degrees plus 24, whoops, not 20, 24 degrees equaling 180 degrees. Now what we can do here is swap round the E and the 180. And when we do this, whenever we cross an equal sign, basically this is now equations that you're going to be doing more of in year 7. You are now going to, instead of be adding, and you're going to be subtracting this total from 180 degrees. So we know that E plus 35 plus 24 is equal to 180 degrees. So let's do this. Let's start off with what we know is the total. 180 degrees minus, and let's add these two, 35 degrees plus 24 degrees is equal to angle E. And so that's going to be 180 degrees minus 35 plus 24 is 59. Oh wait, I don't have to put it in brackets anymore because we've calculated that. It's 59 degrees. is equal to E degrees. And then finally, E, we're going to find is actually equal to 121 degrees. And let's just do that quickly, just to confirm. If I had to add 35 plus 24 plus the angle we've just calculated, which is this one, plus 121, we should end up with 121 degrees, and it is therefore correct. Let's look at a second example. So now in this example here, call it example 2, we have got one of those 90-degree angle triangles, right angle triangle. And we see we only have one other angle given, and we are asked to calculate K. Now here's the thing, this is part of that background information that I told you examiners like to ask you, like to test with you. They want to know if you recognize that this actually equals 90 degrees. If you don't know that, then you're going to be sitting there in the exam saying, how is it fair? They've only given us one angle. I don't know what that is. I don't know what that is. They've told you it's 90 degrees. So this is again background information that you just need to remember. So what do we know about the inside angles of a triangle? We know that they all add up to 180 degrees. So let's start there. And if I therefore know that my one angle is 57 degrees, I can start my subtraction sum. And this angle is 90 degrees. I know that if I add those together and subtract them, what's left of 180 degrees can only be that angle K. So here we go. That is going to be equal to 180 degrees minus 147 degrees. Yes, it should be 147 degrees. And so this is equal to K degrees. That's angle K. I'm writing a bit big for the split screen, I know. So then we just do our straight subtraction. What is 180 minus 147? That is going to be 33 degrees is equal to angle K. So this angle here should be equal to 33 degrees. Let's just double check that with the calculator. We were given one side of that triangle was 57 degrees. We know that this angle here is 90 degrees, so we're going to add that. And now we've just calculated that we think angle K is 33 degrees, so I'm going to add that. And what should we end up with? 180 degrees. So here you see the maths behind it. We did the experiment, the practical side of how it physically does equal 180 degrees, all the inside angles of a triangle. Just remember that there are outside angles, but that's a totally different topic. That's now working from 360 degrees for a full circle. But for today, I hope that this lesson has made sense to you. I hope that you now fully understand the inside angles of a triangle, complementary angles and supplementary angles, because these are the skills that you will need to answer the types of questions that you will most likely be asked in your checkpoint exams. So go ahead and do the assignment that I've set for you, this worksheet. It's going to be this one here. You've got 8 of these examples to do, all based on the information that we've done in this lesson today. Everything is going to be based out of 180 degrees with a bit of addition and subtraction combined. Let me know if you need some help. I hope you've enjoyed this lesson, and I look forward to seeing the work that you hand in. Please remember to draw the triangles, sketch them into your books, do the working in full. I don't mind how you set it out. It's a bit difficult for me to show you the layout here on my laptop screen, but if you can at least set it out something like this, where you're showing the 180 degrees and you're adding the 2 known angles in their brackets, I think then we should have something uniform so that we've got your sketched triangle, or you can just cut out the triangle that's there and stick it into your book, or work it out on the side nice and neatly. I prefer it in your squares actually. Yeah, get your work done, take a picture of it and attach that to your assignment, because this work is something that you'll need in your books also for next term when we get back to school and we can carry on with our revision. Enjoy the rest of your day and have fun with your maths. 180 degrees, proving